All right, welcome everyone. Today we're going to be looking at solving exponential equations by using logarithms. If you recall earlier in the chapter, we looked at something called a common base to solve an exponential equation. And just to kind of make sure this is clear, an exponential equation is just where your variable is in the power or the exponent, and we're trying to solve those. The problem with common bases is one, it's kind of difficult when you have big numbers. And a lot of times there is no common base, at least that's not decimal based. So not always easy to do, or sometimes not even possible to do, but using logs will always work. So it's the more kind of reliable method for sure. Our You can see our four steps. We're going to try and isolate the exponential expression, basically get what's up to the power by itself. We're going to take logs of both sides. We might need to use the power rule. Pretty much all these questions we'll use the power rule, solve, check for extraneous solutions. One note on extraneous solutions, they're pretty uncommon with exponential equations, but they occur in the solvent process. If you ever are taking the logs of both sides and you're taking a log of a negative number, you'll just stop and say there's no solutions. You would kind of realize there's something wrong because if you're trying to do any of the steps in your calculator, you get domain error issues or errors popping up. So you'll probably know if there's extraneous solutions. So I wouldn't overthink it with these type. But looking at number four, we've already got the exponential expression by itself. There's no extra stuff added or multiplied in front of the base up to the power. So we're ready to take logs of both sides. So I just kind of rewrite it like this. We're going to use the power rule. We're always going to move the exponent or the part with the variable in front of our log. And remember, that's always multiplication when you do that. And then we just need to solve this equation. The first thing I would always do is just divide the log part on the left side of your equation over. You're going to need to use a calculator. Just put in log parentheses 92. Make sure you close the parentheses. Divided by log 8. When I did this, I got about 2.17. I usually round to two decimal places. And then now that we've done that, just add 7, and our answer would be about 9.17. If you get a different answer than I did on this key, it's probably, if it's close, it's probably just rounding. Some people keep these in their calculator more, which is not a bad idea, but a lot of times I round it to two places before I get to the end. But yeah, that's kind of the idea. And you might get better at writing this out without is right. Like you might be able to do some of these steps together instead of writing it all out. So feel free because you'll notice there's going to be a lot of things. I'll probably start doing it on the back page. But for this one, we got to get the exponential part by itself. So I want to get rid of this 4. So I'm going to divide that over. And 148 divided by 4 is 37. Now we're ready to take logs of both sides. So I'll have log of 7n equals log of 37. We're always going to use that power rule, move that n in front, and then just divide. Like I said, you're always going to divide this log part on the left side over. Use your calculator, plug this in, because these are pretty much all going to be decimals. And when I did that, I got n equals 1.86. I didn't have to do anything else because I just had n here versus in this previous question up here, I had m minus 7. So I had that extra step or so at the end. So if you, it depends how much you have in your exponent. If it's just n, you'll just kind of divide it over, you'll be kind of done with it. So that's kind of the idea. Let's just look at a few more that maybe have a little bit more going on the back page. If you want to take a look at number 7, you can see the reason this one's no solution is because when you eventually take logs of both sides, you're taking log of a negative number. That's a big no-no. But let's look at number 9. So number 9's not anything super crazy, but we've got a lot of extra stuff before we got the exponential expression by itself. I want to get that 3 up to the n power by itself. So first thing you always want to do is always deal with just like when you're solving a two-step equation, you always kind of add or subtract and then multiply or divide a coefficient. So you'd subtract the 15 over. That would be 344. And now we'll divide the 4 over. And like I said, your goal is to have this, like I said, exponential expression by itself. 344 divided by 4 is 86. And now we're ready to take logs of both sides. And this is where, like, I like to say, I like to save a little bit of write in. I just kind of write it, like, I already know that power is going to go in front, and then I'm going to have log of my base equals log of the other side. I kind of do this in one step just to save a line of write in. And then you would just divide this log of 3 over. And like I said, you'll need a calculator, or I believe you could use Desmos, or even if you just type into like the Google calculator, like log of something divided, it should do it for you. But you should get about, for this one, I got about 4.05. And like I said, I've been rounding to two decimal places. You're welcome to round. I would at least do a couple places, but you could put more, you could put less, kind of at least one decimal place. Don't round to the nearest whole number. Um, all right, let's just look at our last one. Similar kind of deal. Like I said, we got to get the exponential expression by itself. So we're going to add that 3. Going to divide this 8. That would give us 27. And now we'll take the log of both sides. And like I said, I like to kind of do this at once. Sometimes I even write it in. I do this. 7K comes in front. I always start by dividing the log part over. It really doesn't. Sometimes you have a choice of the order. You could divide the 7 and then divide the log 11 if you'd want. But so I'll have 7K equals, when I did log 27, I got about 1.37. So that's sloppy. About 1.37. And then divide that by 7. I usually just kind of keep it in my calculator too, if I can, until the end. But when I did this, I got about 0.20 when I rounded up, I believe. And that's my answer. So these aren't too bad. I hope this is going okay while I'm out. But we'll work on this even after spring break a little bit. I was planning on maybe next week, kind of giving you guys maybe a more fun week, do kind of a detour and do a project instead of all this log stuff. So hang in there. I hope you guys are doing well. If you do need any help, like I said, definitely take advantage of Mrs. Milosevic, or definitely shoot me an email or let me know if you need help with something. But good luck.